Before we even realize it, Betelgeuse could make a supernova explosion to take the night sky all over the world. Its beautiful red color and high position make it a favorite for skywatchers and scientists. But what makes Betelgeuse truly fascinating is its mysterious behavior. Scientists call it a variable star because it expands and contracts over time. This changes its brightness, sometimes becoming very bright and other times faint. Compared to our Sun, Betelgeuse is incredibly huge. It is more than 1,000 times larger in diameter. If we put it in our solar system, it would swallow up all the inner planets, including Earth and Jupiter. Betelgeuse is a massive red supergiant star that is nearing the end of its life because of its enormous size and mass. But its impending death is not the only thing that grabs our attention. There is also a small detail about a supernova explosion to take the night sky all over the world. Astronomers are worried because Betelgeuse has been getting dimmer. In late 2019 and early 2020, it went through an unusual dimming event and lost a lot of its brightness. Scientists were amazed and had many theories about why this happened. The Hubble Space Telescope confirmed that Betelgeuse ejected a large dust cloud, blocking some of its light. But since February 2020, the star has not dimmed again. What we know is that the star's surface is moving like jelly, and the regular 400-day heartbeat that has been happening for centuries has disappeared as the star recovered from the huge explosion in late 2019, which we now call the Great Dimming. The cosmic spectacle known as Betelgeuse, a star situated in the Orion constellation, has piqued the curiosity of scientists and stargazers alike due to its peculiar behavior. Most experts concur that Betelgeuse is nearing the end of its life and is likely to undergo a cataclysmic supernova explosion. However, the exact timing of this celestial event remains uncertain, confounding even the most knowledgeable researchers. Astonishingly, the colossal detonation could transpire spontaneously, even as you read these very words. Numerous astronomers have postulated that Betelgeuse holds the potential to become the next supernova in the Milky Way galaxy. Positioned a mere 1,000 light-years away from our cosmic neighborhood, this luminous crimson supergiant star teeters on the precipice of demise. The pressing question arises: if Betelgeuse does erupt in a mesmerizing display of cosmic fireworks, how close will its explosive finale be to our terrestrial abode? Furthermore, is there a possibility that any among us will have the remarkable fortune of witnessing this grand spectacle firsthand? Astronomical conjecture posits that Betelgeuse is likely to succumb to its fate within the next 100,000 years, a time frame that might seem relatively brief on cosmic scales, but undeniably lengthy from a human perspective. However, this estimation might prove underwhelming to those eagerly anticipating the star's demise. Nevertheless, it remains within the realm of possibility that prevailing theories and prognostications are flawed, and Betelgeuse's explosive demise could unfold unexpectedly, catching us off guard at any given moment. The uncertainty surrounding Betelgeuse's fate only heightens the sense of anticipation and intrigue surrounding this enigmatic cosmic entity. A new study by Hideyuki Sayo and his team from Tohoku University in Japan suggests that the star may be further along in its life and closer to exploding than we thought, but there isn't enough evidence to support this claim. In this case, the pulsations of the star are responsible. Betelgeuse is an unstable star. It expands and contracts regularly. Scientists have noticed changes in its brightness over the past 100 years, with cycles of 2,200 days, 420 days, 230 days, and 185 days. The 420-day cycle is the most important one that astronomers pay attention to. This colossal entity possesses an intricate rhythm of pulsations, revealing secrets about its enigmatic existence. By unraveling the mysteries hidden within its pulsating heart, scientists strive to comprehend the nature of this extraordinary star. The symphony of Betelgeuse's pulsations has two distinct types of cycles: the longer ones, known as fundamental cycles, and the shorter ones called overtones. Among these pulsations, a remarkable 2,200-day period stands out. This extended cycle, known as a long secondary period, is observed in approximately 1/3 of supergiant stars. However, the origins of this peculiar phenomenon remain shrouded in mystery. To grasp the sheer magnitude of Betelgeuse's pulsations, consider this astonishing fact. If we were to designate the 420-day period as the primary one, Betelgeuse would encompass a staggering lineup of 800 to 900 suns. Its vastness would be so immense that, if placed within our solar system, Betelgeuse would extend its reach nearly as far as the orbit of Jupiter. But scientists led by Professor Hiromoto Sayo and his colleagues propose an even grander scenario. They suggest that the 2,200-day cycle might be the primary pulsation, with all the others serving as overtones. In this scenario, Betelgeuse would evolve into a supergiant of unprecedented scale, expanding to a size equivalent to 1,200 suns. Imagine a star so colossal that it would surpass the orbit of Jupiter, engulfing our solar system with its colossal presence. Betelgeuse belongs to the category of massive stars, destined for swift aging. Similar to our own sun, these stars commence their existence by fusing hydrogen into helium within their cores. Yet unlike the sun, Betelgeuse rapidly transitions from hydrogen fusion to the more intense fusion of helium into carbon. As carbon is consumed, new elements of greater mass are synthesized. This process causes lighter elements to ignite in shells around the star's core, causing its envelope to expand, resembling a magnificent hot plasma balloon. To unravel the intricacies of Betelgeuse's life cycle, Professor Sayo and his team employ sophisticated simulations that meticulously track the star's journey from birth to death. By predicting the pulsations that occur at each stage, they gain profound insights into its evolution. Through their analysis, they assert that Betelgeuse's pulsations, spanning from 2,200 to 185 days, are the result of a dying star in its final stages of carbon burning. Astonishingly, they also predict that the star's core will collapse within a few decades, triggering a cataclysmic supernova explosion. However, pinpointing the precise moment when carbon will be exhausted remains an elusive challenge. At this advanced stage of the star's life, the pulsation periods have stabilized, rendering it difficult to determine the remaining amount of carbon in the core. As Professor Sayo notes, the estimation of carbon depletion cannot be precisely estimated at present. In the words of one researcher, the time until carbon exhaustion is merely conjectured to be less than a few hundred years. Betelgeuse's pulsations serve as a symphony of cosmic revelations. Amidst the interstellar orchestra, scientists endeavor to decipher the enigmatic melody that emanates from this colossal star. With each pulsation, we inch closer to understanding the secrets held within its luminous heart. As we gaze up at the night sky, let the awe-inspiring story of Betelgeuse remind us of the grandeur and mystery that resides beyond our earthly boundaries, awaiting our exploration. Sayo's team has an intriguing prediction about the fate of Betelgeuse, but don't expect an explosive event anytime soon. Contrary to sensational headlines, these scientists assert that Betelgeuse won't go supernova tomorrow, or even within the next decade. Instead, they estimate that the fiery spectacle will occur 1,000 years from now. While this time frame is considerably shorter than the more typical durations of 10,000 or 100,000 years, it's still quite a long wait. To grasp the complexities of Betelgeuse's behavior, let's delve into the fascinating world of pulsations. If the star's pulsation is radial, a phenomenon where the surface expands and contracts, it presents additional challenges. Through spectroscopic observations, astronomers have discovered that Betelgeuse experiences this pulsation at an astonishing rate of roughly 3,300 kilometers per hour, or 1.5 kilometers per second. Over a span of 2,200 days, this pulsating motion resembles the star's rhythmic breathing, causing its diameter to change by a mind-boggling 180 times the size of our own sun. Even seasoned astronomers find this immense scale daunting. But the 2,200-day pulsation doesn't stop there. It also affects another pulsation known as the overtone. Consequently, the regular 400-day cycle is far from constant. As the star expands to its maximum size, the overtone pulsation lengthens, and as the star contracts, it shortens. MacLeod, one of the researchers involved, explains that these changes should repeat systematically every 2,200-day cycle. However, upon analyzing Betelgeuse's long-term light curve, they observed more random variations around the 400-day typical cycle. Before we moor any further, Please subscribe if you still haven't. For those unfamiliar with stellar evolution, here's a brief primer. As a star exhausts its hydrogen fuel, it transitions into the next phase, where helium begins to burn, ultimately transforming into carbon. This process causes the star to expand once all the available fuel is consumed, and the remaining elements cannot sustain further fusion reactions. The star's core collapses, giving rise to a solid neutron star. The outward pressure exerted by the surrounding gas then triggers a dramatic supernova explosion. Betelgeuse has already lived a remarkable lifespan of at least 8 million years. It is believed to have depleted all the hydrogen in its core, signifying its proximity to the end of its stellar journey. Will we have the chance to witness the spectacular Betelgeuse supernova firsthand? Unfortunately, the answer is a resounding no for us mere mortals, unless we could somehow extend our lifespans by several thousand years. Be sure to watch this captivating on-screen video to learn precisely when the supernova explosion could occur. It's closer than you may think.